So in this video, we will be looking at how to solve systems of equations using matrices with a calculator. So solving a system of equations using matrices, we used what is called row reduced echelon form, or RREF, on our calculator. This uses an augmented matrix with row operations to get to the identity matrix with solutions. An augmented matrix is matrix mode from the system by removing the variables, and it needs to be in order. So if a variable is missing from the equation, a 0 is used in the matrix as a placeholder. So for example, on our first problem here, we would put this 2, 1, so the coefficient here of x is 2, the coefficient of y is 1, and then the 6 for the constant. Then this equation would be -1 for this coefficient, 1 for y's coefficient, and 0 for that constant. And then we would put that into our calculator, and then we would push the reduced row echelon, and then we would get our solution. And what the solution is this says 1x, or x, equals, and this is our solution here too in this column. This would be our y, and it is 2. So it gives you the solution. Now remember, with systems, we can have 3 types of solutions. We can have an actual answer, kind of like what we did up there. So we have a solution when there's 1s on the diagonal. So here's our 1s. With 0s above and below. And then the solution is the last column. So right here, the numbers. And then this one, we have when our last row is all 0s except for the last number, it is no solution. So for example, we had like 0x plus 0y equals 1. So no solution. Okay. And then this one is our third option that we know we can get, and it is infinite solutions. So we don't have diagonals, we don't have 1s diagonally, so we know it's special. And when we look in our last row here, and it's like 0x plus 0y equals 0, that's true. So we have infinitely many solutions. Last row, it's all 0s. So what we're going to do is take a look at this matrix equation here, and remember that we have x, y, and then this one has a z, and then these are all of our constants in that last column. This is a 3 by 4. So what this would actually look like if we had the equations would be a x plus 3y plus 2 equals -3 for that first row. Negative x plus 6y minus 4z equals 9. 5x minus 2y, and then there's no z, equals 10. So this is the system of our matrix up there. So go ahead and try doing that, changing this into the system. So again, this would be your x, this would be your y, these would be your constants. Again, this is a 2 by 3. So what would those equations of the system be? And hopefully you got that. So let's go ahead and practice typing these into our calculator to solve. So we're going to open up our desmos.com/matrix again. And we're going to bring that over. And we're going to first write our matrix before we type it in. So what our matrix is going to look like is 1, 1, 1, 14, 4, -1, 5, -22, 2, 2, -3, 35. X is here, Y is in the second column, Z is in the third column, and constants in the fourth column. So we're going to come over here and create a new matrix, and we're going to enter, after we make it the right size, a 3 by 4, and we're going to enter all of our numbers. And then we're going to come over here and hit the RREF, and then we're going to put A, since we're looking at matrix A, and then we're going to convert to fractions, and then we have our answer. So we have, let's go ahead and write it out first, and then we'll interpret. So you can see our diagonal of 1s, which means we have a solution. So the x is 2 over 25. The y is 383 over 25. And the z is -7 over 5. So I want you to try number 2 on your own. So plug that into Desmos after you write it as a matrix to find your solutions. So here's the matrix you should have put into your calculator, making sure that you had a 0 on that second equation for the y value. And then we'd use our reduced row echelon form, and we've got our x equaling -4, our y equaling 7, and our z equaling 1/2. All right, so what happens if we have a 45% acid solution is mixed with a 15% acid solution to get 16 ounces of a 30% solution? So the question is, how much of each solution is needed? So let's have x equal the amount of our 45% and y equaling the amount of our 15%. So when we take x plus y, we're going to get 16 ounces. And then when we take 0.45, 45% of our x plus 15% of our y, we're going to get 30% of our solution, which is 16 ounces. And so when we put this into a matrix, we have 1, 1, 16. We have 0.45, we have 0.15, and then 0.3 times 16 is 4.8. So we're going to plug that into our calculator. and then reduce row echelon of b. So we get a solution of x equaling 8 and y equaling 8. 8 ounces of each.